Hello and welcome to the Homeless Consultant channel. My name is Paul B. I am the Homeless Consultant. In this video, this is installment number 6, I believe, on the topic of junk science, which is Existential Threat to America, number 6. So when I first started talking about junk science, I thought I could do it all in 1 hour. Sometimes you should know better. And it has just kept adding installments on this topic, expanding like a Big Bang universe. When will it end? Will it ever contract? We'll see. In this particular installment, which I think is going to be one of the more just interesting ones, I basically have 3 topics to talk about. I want to talk about the redshift controversy. I want to talk about opposition to junk science becoming cults in their own right, and I want to talk about support and cottage industries for junk science, which affect our ability to stop junk science. So let's get started, shall we, because this is the umpteenth time I have recorded this episode, and I need to get it done. I'm trying to squeeze it in an hour, and I lost my place already. Okay, so let's see. Let's start out with redshift. Alright, now I touched on this on an earlier video. What redshift is essentially what's called the Doppler effect, or you can think of it that way, supposedly. Again, when any vehicle, but a siren, like a police siren going by, as it passes, it starts out higher pitched, and it goes to lower pitched as high pitched as it's coming towards you, and then it goes to lower pitched. So it'll go. Alright, so the pitch is dropping. You've got the which is the high pitch, and then the which is the low pitch. And it basically right in front of you is where it drops. In theory, when it's right in front of you, it would be the real pitch. If you were standing still and the siren's just sitting next to you, that's the, quote, real pitch of it. Okay, and what's happening is, sound waves, they're like, if you think of them as sine waves, which isn't true, but if you think of them as just going up and down like on an oscilloscope, periodic, the distance as I'm going up, down, up, the distance here, well, the distance of a full wavelength is inversely proportional to the frequency. In other words, how frequently these things occur, these up and down motions occur, is inversely proportional to how distant it is between them when you measure them out. The distance between them is the wavelength. Okay, so if you have a short wavelength, it's going to go like that. If you have a long one, it's going to go more like that. I have to even take it off the screen. The frequency is, to our ears, is the pitch. So if you have a high frequency, okay, frequently, da 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 da, it's higher pitched. If you have a lower frequency, like this, where it has a wider wavelength, it's lower pitched. Over there. And what happens is when something's coming toward you, it is pushing and compressing the waves. So if this is the normal, if you're standing still, if this is the normal sine wave, if this is the normal wavelength of the sound for real, then as it's coming towards you, instead of being like that, it's going to get compressed and become a little more like that. And that is what raises the pitch. As it leaves you, it's like a slinky. If you take a slinky and you're holding it and you let go and you run away, it's going to stretch out, right? And then it'll fall, but it's going to stretch out. Well, as it's leaving you, the sound waves are stretching. So then if you have this as your normal wavelength, it's going to stretch out to something much bigger. And that's a lower pitch. I forgot what pitch I was using there. I don't have perfect pitch. Alright, that's basically the Doppler effect. It's a cute thing for kids in a museum or whatever. As a sound goes by you, it drops in pitch. Now, that's with sound. Sound wave is pressure of actual air that is pressing against the mechanics of your ear to eventually produce sound in your brain. But the same thing happens with any kind of a wave. in nature. So light from the sun, for example, light from the stars, light from the moon, from galaxies, that also has wavelength, and therefore it also has a frequency. Now, we tend to talk about the wavelength more than the frequency. The frequency is going to be the difference between visible light and microwaves, radio waves, ultraviolet waves, okay? The frequency determines those differences. Within visible light, it determines colors. You know, red on one side, blue on the other, and this rainbow of colors in between. So, in theory, this is just fascinating. I love this stuff. This is what made astronomy so much fun for me when I was a kid, before I knew what was really going on. If you have a star at a great distance, it's emitting energy toward us, which we capture with a telescope or some other device. Specifically, it's going to emit photons, packets of light. And it's going to come to us at a certain... it's going to come to us with a full spectrum. So if we do what the Pink Floyd album Dark Side of the Moon, right? It has a prism on it. The white light comes in and it separates it out into the rainbow of colors. Same thing that causes a rainbow in the sky, for that matter, right? And the chemical composition of that star is going to make some changes to the light that comes through here. So the light that comes, let's say there's helium and hydrogen and lithium in this star, just for the sake of argument. It's going to, when the light hits us and we break it up into a spectrum, there's a bunch of dark lines in there. There's a bunch of lines, you'll see them as, they're different toned than the nice smooth spectrum from one color to another. So there's obviously some kind of break going on there. These are called emission lines and absorption lines. And basically, when atoms up there, drop to a lower energy state, it emits a photon. So there's an emission line. When it's passing through, say the light passes through hydrogen, it's going to create certain absorption lines. It's going to create certain lines that they're like a fingerprint. You can just look at a chart of these particular lines in this order. This spacing tells you that there's hydrogen in there. This tells you that there's helium in there. This tells you that there's lithium in there. Fascinating. Those things are light years away. Some of them are millions of light years away. That's the neat thing. Now what happens is, as we view an object, we know where those lines should be for hydrogen and what they are relative to each other. So let's say you've got these three lines and they're spaced like this. What happens is sometimes we look at the spectrum and you've got the same configuration, spacing, but it's shifted. The whole thing's shifted over toward the red. Okay, or it could be shifted toward the blue, but we're usually talking about red shift, not blue shift. When it's shifted toward the red, it's the same thing as the siren going by you. Okay, that means it's shifted toward a longer wavelength. And that implies that it's going away from you. So in other words, you can tell that the star is moving away from you in theory because it's shifted to the red. If it's shifted to the blue, then the star is coming toward you. And that's pretty fascinating. Again, these things are millions of light years away. So the scientists say that there are three things that cause this redshift. One of them is the Doppler effect, which I just told you about. So that tells us whether it's moving away from us or toward us. And in fact, it actually tells us how fast it's moving away from us or toward us. There's also, since they believe in Big Bang, everything or nothing went boom and became everything. And it's expanding outward. Everything's moving away from a central point. This expansion in what this curved space-time, they're going to use all that terminology. Curved space-time creates what's called a cosmological redshift. In other words, it's the expansion of the universe. But just like with those lines that are relative to each other stay the same and they just shift, if everything's expanding at exactly the same rate, then relative to each other, nothing changes. It's just that they are in fact moving apart because they're expanding. You know what I mean? So in other words, if you draw a picture on a balloon, draw a happy face on a balloon, and then blow up the balloon, the proportion of the face remains the same, it just gets bigger. It's the same thing. That's what they call a cosmological redshift. And then there's a third one, gravitational redshift, which gets into general relativity. I'm just going to ignore that one for now, because I'm going to start enough fights with this video as it is, without attacking Einstein. So let's just forget about that one for now. The main thing I want to worry about is Doppler effect. Okay, now since the expansion doesn't change anything fundamentally, it changes their relative position, but it doesn't tinker with the fundamentals that we need to determine how fast it's moving away from or toward us. So if you believe that that's the case, in theory, with some mathematics and equations and such, you can determine how far away that thing is as well. Now, if the redshift is extremely high, let's say this thing just all the way over, that means it's moving extraordinarily fast away from us. And that's where astronomers start making assumptions. Actually, they make one assumption first. They're making an assumption that what they're observing has not been interfered with in the 13 billion years that it's been traveling to Earth. In other words, when the photon left that distant galaxy and it's on its way to Earth over billions of years, there was never, say, a cloud of gas that moved in between the photon and us. You know, and the photon went through the cloud and it had the composition of the cloud absorbed, so that our absorption line isn't really accurately describing the original object that emitted the light. And when you're talking about billions of years, it's possible that the thing could travel through a whole bunch of clouds and dust and such that might absorb. Heck, something could happen to cause some emission. You don't know. That's my point. That's been my point all along. You don't know what happened in the past. But astronomers do, because they have really big heads. Their heads are bigger than yours. There's a thing that they discovered in the early 60s called a quasar. We call it a quasar. It's called a quasi-stellar object, or a QSO. Most people call it a quasar. Now, you could always see them. They were always in photographs. You could always see these things. So it's not like they discovered something new. The difference is that when they measured the redshift, they had properties that didn't make sense. They didn't match other objects. Specifically, they had extremely high redshifts. In fact, the redshifts were so high that by all appearances, and when you run these calculations that they use, that the scientists use, it looks like what's going on is this thing is the furthest away from us of anything. In other words, if there was a big bang, boom, and you've got this sphere of material moving away from each other, then if we're over here, it's the stuff that went out first way over here that we're seeing. In other words, that's supposed to be the outer edge of the universe that you're seeing. Now, if you just think about it, there's a few problems there. I mean, for one thing, if it goes boom and everything's expanding at nearly the speed of light at the very beginning, what does that mean? Well, this is expanding at nearly the speed of light, but guess what? So is this side. If you add the two together, then relative to each other, they're moving away from each other at nearly twice the speed of light. But scientists have answers for this. They have answers for this. That's a childish interpretation of reality. Yeah. But having said that, I will say that if you have two cars that are parked with their rear ends together and they take off until each one's going 60 miles an hour, relative to each other, they are moving away from each other at twice that amount, 120 miles per hour, relative to each other. See, the speed of light you can't exceed the speed of light according to standard science. You see, that's my point. If you had a big bang and things are taking off at nearly the speed of light over here and over here, then relative to each other, they're expanding away from each other at almost twice the speed of light, which means they're breaking the speed limit that Einstein supposedly set for us. Just one of the interesting things about standard astrophysics. these quasars had a lot of properties. Another property that was fascinating with these is that the fact that we can see them at all, let alone that we actually photographed a lot of them back in the 60s with relatively primitive telescopes to what we have today, the fact that you could see them at all and they're supposedly literally on the other side of the universe means that these things have to be incredibly luminous. Let's say you have a 10-watt light bulb right here, and you look at it, and if you stare at it, it's going to be pretty bright. It's going to be, might make you squint a bit, but it's not overwhelming. But then you put a 150-watt light bulb over here next to it. I mean, you almost won't even notice this one anymore once you turn this 150-watt on. It's so much brighter. Okay? When you run the calculations, the upper limit of how luminous a quasar must be was something along the lines of 100,000 times the luminosity of the entire Milky Way galaxy. And this was supposedly something that was spit out at the very beginning of the Big Bang. Okay. I didn't make this up, folks. The scientists did, alright? I'm sorry. But they're saying that this little quasar way on the other side of the universe is as much as 100,000 times brighter than the entire Milky Way galaxy. That's the only way we would be able to see it. If it were dimmer than that, then we wouldn't receive enough light to even see the thing. That's impossibly bright, first of all. And there's a lot of other things with quasars that drew people's attention. So here's what happened. A man named Halton Arp took up this challenge to figure out what's going on. Halton Arp was one of those people who NPR would have interviewed early on. He had all the credentials. He went to Harvard. He had, you know, he had the awards, the accomplishments. He was in California, working at Mount Palomar Observatory. At the time, that was the largest telescope in the world, 200 inches. And you know, that was the Hubble telescope of its day. When I was a kid, I wanted to work there at Mount Palomar. As it turned out, the only experience I have with Mount Palomar is the engine of my vehicle exploded on Palomar Mountain when I went to see it. Cost me a couple $1,000s there, but that was a long time ago. And it wasn't my fault. I just bought the car and they don't have a lemon law that works in California. That's what happened there. Just for the record. Halton Arp, among other things, he created the Atlas of Peculiar Galaxies, which is a great reference tool for astronomers, astrophysicists. These are galaxies, you know what the Milky Way and the Andromeda Galaxy look like. Beautiful spirals, nice and symmetrical. When they use all the false color, they come out really beautiful. But they don't all look like that. Some of them look like something when you squat outside in the woods and drop it on the ground. That they kind of look like that. It's a peculiar galaxy. Alright, but he created this atlas of these, which again as a reference tool is very useful. So he became famous for that. But his specific interest was these galactic, interstellar, these distant objects that are interacting with each other. Now, keep in mind, if you look through a telescope and you see two bright stars, like Castor and Pollux, right? Gemini, the two bright stars, Castor and Pollux. If you see these two stars and they're about the same brightness, can you assume that they're at the same distance? Can you? Because what if, when you go to the side, it turns out that one of them is much more distant, but it's a lot brighter. So if you account for its distance and the fact that it's brighter, they look like they're right next to each other. They look the same brightness from our perspective, even though this one's a lot brighter. Well, how do you determine that? You can't see from this distance. You would have to fly a probe way out to these other galaxies and look at it from the side. You can't do that. So how do you determine the relative distances of these? Well, one way is through redshift, the Doppler effect. And from that, what they did was the astronomers created a catalog of, you know, all the stars, the brightest stars in the sky and everything, all these objects, and in the specifications for each star, as they're listing out their characteristics, there's a column for redshift. from that, when you take all that data, that's what astronomers take and they work with it. They start massaging it, they start thinking up hypotheses, and they start formulating experiments and things like that. That's what science is supposed to be doing. But the thing is, what if the redshift column in that thing is wrong? What if what we're seeing isn't really a Doppler effect? That means that everything that scientists have been doing based on this chart of information about these stars, specifically with the redshift, everything they've been doing for the last 100 years or so was bunk. It was based on a completely false data. And it means that everything they've taught you and your parents and your grandparents, and if you're young, if some families, your great-grandparents and your children today, they might be teaching you the wrong thing. And yet you're paying for it. How much did you pay for tuition in school? How much are your kids paying? How much student loans have you taken out for that? If that column is wrong, we got problems, friends. Holt and Earp felt that there was something wrong. And here's the trick. The actual evidence seems to support his interpretation of things. And he's not the only one. I picked him out, but he's not the only one. I think he has the most sensible interpretation of this. Here's what happened. The thing with quasars is that they're often clustered. So if you have a galaxy, let's say you have some spiral galaxy sitting right here. If you saw a quasar here, you would usually see a quasar here as well. Here and here. If you see one way out here, you would usually see one way out here. In other words, there was like this symmetry. But according to standard science, these quasars at the edge, they're way out there. They're way at the edge of the universe, whereas this galaxy in the middle is relatively close to us. Remember, you can't tell relatively how far away they are unless you make assumptions about the redshift. Well, according to the redshift, that's exactly what you have, is a galaxy that's relatively close to us, and you have these quasars that are way distant from us. But the thing is, does that make any reasonable sense? If every time you look around the sky you find quasars, and they're clustered around some other galaxy in a more or less symmetrical manner, and there were some other things going on. He found that the actual redshifts were quantized, which is a big, big, big deal. If you make music, if you make drum beats in music, I have my sticks here, but if you, 1, 2, 3, 4, what if you're a crappy drummer, and instead of doing this, you go, because you can't keep a beat. If you use something called a quantizer when you're recording, what it does is it takes the beat that you hit and it moves it to the closest quarter note. So when you play it back, it goes, even though you played. You see what I mean? It makes packets of reality, and it shoves everything into the nearest packet. And that's what they were finding with the redshift. That doesn't make any sense. Why would quasars on the opposite sides of a supposedly much nearer galaxy have quantized redshifts, which implies a symmetry that is related to the galaxy? Because the quasars are supposedly way out at the other side of the universe. You know, boom! Big bang. Well, as he looked at it, like I said, another thing that Holt and Earp was into was interrelations between celestial objects. Sometimes what you would see is this galaxy, and you would see the quasar, and again, you don't know how far apart they are from each other, but when you looked at it from this direction, there was a clear physical link. There was matter spiraling out of here and into the quasar. Now, it is possible that there's a hook there, and when you look from the side, this hook's just hanging over here, but the quasar's back here. It is possible. But after you see enough of these in the sky, at some point you start to figure out, that's not what's happening. These literally are physically connected to each other, which means that this is not a zillion light years past this. They're related. They're near each other. They're pretty close to each other. And that's a whole nother story. Remember how luminous this thing has to be that far back? If it's at the outer edge of the universe, it has to be hyperluminous, I mean incomprehensibly luminous, for us to see it at all. Well, if it's actually much closer to us, like this galaxy is, it doesn't have to be that bright anymore, does it? So there's another property that's wrong in the charts that these people use for their life's work in astronomy and astrophysics. You can see the problem with what Halt and Arp was coming up with. It was chipping away at the fundamental assumptions of astronomy.
Miss Olaf, you should never assume, because when you assume, you make an ass of you and me.
Halt and Arp wrote a paper, and he sent it into the Astrophysical Journal. That is the big journal, academic journal in astrophysics. If you get published in the Astrophysical Journal, you've got it made. Your career's set. If you get refused, at least, especially several times by the Astrophysical Journal, you got problems. You're going to be sweeping floors. All right? The guy who ran the Astrophysical Journal at the time, therefore, was essentially the most powerful person in astronomy. He determined who lived and who died as an astronomer. And at this time, the guy's name was Chandrasekhar. Very difficult for me to pronounce. And Mr. Chandrasekhar had a really big head. His head was much bigger than yours or mine. And yet, when he got the paper from Arp, he just wrote in the corner, he wrote, "This exceeds my imagination." He just wrote it in the corner, and he sent it back. But he didn't send it to Halt and Arp. Interesting. This guy who makes or breaks people in this field, he sent it to Arp's boss. Interesting. Why would he do that? Why would he send it to his boss? You know, the answer might lie in what happened after that. Because what happened after that is Arp's boss called him into the office and he said, "You need to look for another job." You see, because if Arp was right, everything they've been teaching you, all the money they've been charging you to teach you this stuff has been wrong. And guess what? When you charge money for something and they give you something other than what you agreed upon, it's fraud. It's a criminal offense. There's civil penalties, there's criminal penalties. People go to prison for that and they have to pay you back for what they stole. And they've done it to you, your parents, your grandparents, possibly your great-grandparents, and they're doing it to your children. And they're encouraging you to take out student loans, which are a financial death sentence for so many people, in order to have the privilege of being taught this. If Arp is correct that what they've been teaching is wrong, I think you can see what the problem is just from that alone. But more importantly, if Arp was right, then its impact on the interpretation of standard science of what's going on, mainly, boom, flies out the window. And that's a problem for junk scientists. People who do not want to know the truth. They want to justify, boom! That's the only thing they're concerned with. Finding out what's really going on out there isn't their concern. Now, Arp asked him to put that in writing, that he needed to find another job. His boss apparently was too scared to do so, for obvious reasons, so he kept working. But after a while, there's documentation of this in the organization. They said, we're going to cut off Arp's telescope time. Now, if you're an astronomer, especially if you're at the world's largest telescope at the time, and you get your telescope taken away from you, again, your career's over. That's like if you're a medical doctor. Let's say you're a medical doctor and the government takes away, or your employer, they let you keep your license, they let you keep your degree that you earned in college, they let you keep your office and your equipment, but they take away your patients. They say you can never have any patients ever again. Are you still a doctor, or are you just a poser? That's my stomach. I'm very hungry in this car. Don't get to eat like I did when I had a home in a kitchen. Sorry. if someone takes away your telescope time as an astronomer, you're finished. That was the straw that broke Arp's back. So this man could really no longer work in his field in the United States of America with all this brilliant science. He had to move overseas. He moved to Germany and joined the Max Planck Institute there. So America lost the extraordinary talents of this scientist. And those talents were picked up by another country for the purpose of preventing him from exposing, possibly, I'm not saying that this is all settled yet or anything, but what he came up with was highly compelling, and the evidence seems to support it. The idea of legitimate science not looking into it is ludicrous. You talk about a hypothesis that deserves to be researched. This is it. Junk scientists won't touch it. They won't go near it for the reasons I've already stated. All right. What Arp was talking about was basically saying that, because remember, when you have the two objects next to each other, the quasar does in fact have a huge redshift compared to this. How do you explain that? Well, obviously something else is affecting the redshift. So you have the Doppler effect, yes, on the one hand, but there's something else affecting it as well. And guess what? If something else is affecting it, then the redshift has no meaning as a Doppler effect. It doesn't matter anymore. Yeah, there might be a Doppler effect, but you can't put it in the tables along with the star characteristics. You can't put it in there and then have people devote their careers to using those tables for their science because you don't know what the redshift means anymore. So all these people have wasted their lives and their careers using data that was garbage to begin with because these people made assumptions, which is what junk scientists just keep on doing. Another problem with what Arp was doing was that a lot of his research was backed up by amateur photography. So you had amateurs sitting in their backyard with maybe a 6-inch or an 8-inch or maybe even a 12-inch, 16-inch telescope. And the photographs they were getting back were so good that you could see the matter going from one object to another, that they were connected, that they were related. That humiliates these junk scientists who control academia. They've got a 200-inch telescope, and they've got even bigger ones today. They've got the Hubble telescope, and guess who paid for them? You did. Your tax dollars. You went to work and earned money. That money was taken away from you at gunpoint by the government and given to these guys to build a telescope. For what? So they could come up with a table of information that's completely wrong and then lie to everybody going forward for generation after generation after generation? Yeah, that's exactly what happened. Here are just some of the implications. If Arp is right about there being an intrinsic redshift, and I won't even go into what he thinks causes it, I don't have time. It's fascinating though. If he's right about that, here are the implications of it. First of all, boom! Never happened. Which is kind of what a small child would think. Because a small child would probably say something like, well, what is it that went boom? What went boom? Where did that stuff come from? You know, questions like that. Questions that astronomers don't want to answer. You know, maybe it was created by a designer, perhaps. Seems plausible, but another thing is that there's no expanding universe. The idea that the universe is constantly expanding, remember, one of the types of redshift, supposedly, is this expanding redshift. How convenient it is. Remember the balloon, if you draw the face on the balloon and blow it up, the face retains its proportions as the balloon blows up, unless you've got some kind of weird deformed balloon. But if you have a spherical balloon, if you were a little tiny thing standing on the balloon, the proportions would always look the same to you. You're not going to know that you're on some expanding balloon because the face always looks the same. It always looks like a face. It doesn't morph into a goat just because it's expanding, because everything's expanding proportionally. In other words, all this talk about a redshift due to the expanding universe is nonsense. Once again, you can't detect it. How are you going to detect it if everything's proportionally moving away from it? Just, oh gosh. Another consequence of intrinsic redshift, there's no such thing as black holes. Oh, everyone loves black holes. Sorry. When I was a kid reading Isaac Asimov's books, that's one of the things that made me scratch my head. The idea that a star had collapsed on itself so much that the something like our sun, 1,000,000 times larger than Earth, it had collapsed into something that's just a microscopic size, microscopic part of a pinhead. All that matter compressed into there. It creates so much gravity that even light can't escape. And even as a kid, I was just like, that makes absolutely no sense. What is wrong with you people? Just think about it. That doesn't make any rational sense. Well, intrinsic redshift sends black holes packing. Dark matter. Remember the astronomers? They couldn't find the numbers to support their Big Bang theory that they know they're right. They've got PhDs, big heads. They can't be wrong. So they're just going to assume that all that matter is there, and they're going to call it dark matter and dark energy, and we'll let some future generation actually detect it. We know it's there because we can't be wrong. Intrinsic redshift, there goes dark matter, there goes dark energy. Means we live in a steady state universe. I'm not even going into that. Why bother? Here's a fascinating one, though. It also implies that mass is variable. You can think of mass as the weight of something. That's not true, but you can think of it that way if you're not scientifically minded. You know, this mouse has a certain weight to it, but it has a certain mass, and that's what's most important in physics. But if I weigh this thing, let's just pretend it's weight. It isn't, but let's pretend mass is weight. If I weigh this, and then I go to another calibrated scale, it should weigh the same. And then if I come back 2 weeks later and weigh it on the calibrated scale, it should weigh the same. Can you imagine if you went and got on a scale and you weigh 300 pounds, and then the next day you go get on the same scale, which is still calibrated, and now you weigh 180 pounds? That's a diet I can make some money with. Tell me how you did it. If mass is variable, we got problems, friends. In other words, if weight, you might think of it, is variable, the universe isn't functioning the way they've been telling us it's been functioning. There's this equation by Mr. Einstein. You may have heard of it. It's called E equals mc squared. E equals mc squared. That equal sign means that there's an equivalence. There's an equality here. Energy equals is equivalent to the mass times the speed of light squared. And remember, according to them, speed of light, absolute. Can't be violated. It's the speed limit of the universe. Can't go faster. Well, if mass is variable over here, that means that, since it's an equivalence, energy is also variable. Uh-oh. And if you do a little shuffling around of the equation, real simple, just take the mass and move it over to the other side, it implies that the speed of light is also variable. Uh-oh. Which basically implies that E equals mc squared. Gone. Or if it's not gone, it certainly has a different meaning than it did before, doesn't it? Speed limit of the universe, gone. It could even conceivably help answer the distant starlight problem. The distant starlight problem is basically the question of, well, if everything went boom, how is this light even reaching us? I mean, it's going at the speed of light. Well, what I was saying before, you know, if this is expanding at nearly the speed of light, and this is expanding at nearly the speed of light, at least at the right after the Big Bang anyway, then how's this light even reaching us? Or even if you're a creationist, if you say God created the universe, well, if he created the universe 6,000 years ago, as the Bible seems to indicate, well, then how is light from something that's 1,000,000 light years away from us, how's it reaching us? It can't travel that fast. Right? And that's one of the questions they ask. And of course there's proposed answers. Sometimes you can't know everything, can you? But But this might help with the distant starlight problem. So you can see why what Haltnerp came up with, and others, he's one of the people, not the only one, he had to be shut down. That's why the big brain Chandrasekhar just wrote on there, "This exceeds my imagination," and basically sent it to his boss, which is the implied message there is, get rid of this guy and do it now. We do not want this guy ever impacting the public, because if he brings something like this to the public, everything we've been telling people for a century could be completely wrong. Everything we've been charging them money for, especially in college and with student loans, could have been a lie, which is fraud. If they know that it's a lie. If they knowingly did this, then it's fraud. And the problem is, there's a lot of good ideas, there's a lot of good evidence that they do in fact know that this is a complete fraud. For example, when someone submits a paper to Chandrasekhar, and instead of publishing it for fair consideration by other scientists, he sweeps it under the rug by trying to get the guy fired. That implies that he was made aware of the fact that there is a challenge to Big Bang that's very legitimate, and he chose to shove it under the rug. That kind of fraud is a criminal act, especially when you're drawing up public funds to pay for that fraud. Let's go to Wikipedia, that bastion of truth and truthful facthood. Wikipedia, if you look at the Wikipedia page on redshift, it's a big, long, drawn-out affair. It's filled with equations. You've got integrals and derivatives here. You've got all these scary symbols. And the purpose of those symbols is to scare you off so you won't read the Wikipedia page about redshift. Because if you're a scientist, if you're an astronomer, you're not going to go to Wikipedia to learn what redshift is. You're going to go to a professional text. Wikipedia ain't it, especially when you know all the flaws that there are with Wikipedia. So what are all those big complicated equations doing there? No legitimate astronomer is going to go to Wikipedia to learn what redshift is. Why is it there? It's there to scare you off so that you won't read it. Because if you read too much into it, you might start to figure out there's a problem with it. Although it's going to be kind of hard to do it right now because there's only one line in Wikipedia's redshift page that even addresses the intrinsic redshift issue. And it doesn't even call it intrinsic redshift. Here's the line. I quote from Wikipedia, "Alternative hypotheses and explanations for redshift, such as tired light, are not generally considered plausible." End of quote. That's all it says. All this stuff that Haltnerp did and others have done, all of this evidence, quantization of redshifts, the symmetry, the visual matter going from a galaxy to a quasar that implies that they're related to each other physically in physical space, and so much more. All of this evidence, they just throw it out and put in one line. Alternative hypotheses, there's that word again. Alternative hypotheses and explanations for redshift, such as tired light, are not generally considered plausible. Really? Not generally considered plausible by whom exactly? Well, by academia, which is a cult, you see. I could care less whether they think it's plausible. They're a cult. Why do I care about that? What do I care about that? Nothing. But if you're just some random reader who goes into Wikipedia and looks at this and you don't know that academia is a cult, that sounds like the consensus argument, doesn't it? Which is a fallacy. Well, all the respectable scientists think that this is not plausible at all. Oh, gee, well, if all the respectable scientists think it's not plausible, then it must not be plausible. I'm not going to waste my time with it either. They're just blowing this off. And here's another interesting thing. Wikipedia does this all the time. Or not Wikipedia, but the people who maintain the Wikipedia pages, which are the junk scientists. They have control over it. Can't get truth in there. Look at the example they use. Tired light. Tired light is another explanation proposed for intrinsic redshift. Now, when you hear tired light, what do you think of? Do you think, wow, that's That's a respectable hypothesis. We should look into that more. Or do you just visualize in your mind light leaving a star 10 billion years ago on its way to Earth, and it doesn't even get halfway here before it starts yawning and going, oh my gosh, are we there yet? How far is this Earth? I am so tired. Oh, you just picture the rays of light, the photons, just exhausted, just like, oh, are we there yet? You know how silly that sounds? The idea of tired light is a legitimate suggestion. I don't agree with it, but it's legitimate. It's a scientific proposal. But these people who want to discredit it, they call it tired light. Oh, I'm so tired. That's what Wikipedia does to scare you off. If you read only this about redshift, because all those equations are in there, you're going to think it's legitimate. Because you see all those integral signs and all these symbols from mathematics that you can't fathom. And then hidden in there is just this one-liner that just discounts the whole idea of intrinsic redshift. And I need a sip, because I'm choking here. And that's cold. I'm sorry, folks. It is so cold in here. Oh, my gosh. Alright, so that's all I'm going to say about intrinsic redshift, or the redshift debate. It's a fascinating topic. I'm actually I'm gonna link in here a link to Halton Arp's own presentation on this. It's anything but complete, but it's fascinating to watch, and I think he presents it in a way that most people can understand. The man had his career destroyed because he just was looking for the truth, and he was following the evidence there. That's junk science. Alright, now the next thing I want to talk about, oh, by the way, Halton Arp died in 2013, so he's never going to see the fruits of his labor, is he? No Nobel Prize for him. Rest in peace, Chip, and thank you so much for what you did. Next thing I want to talk about is opposition to junk science becoming cults in their own right. There's another movement toward a total redefining of the way we look at physics, astrophysics. It's called the electric universe. And basically it's a way of saying that instead of gravity being the dominant force in the universe, which, relativity and all that, the standard science is going to believe that gravity is the driving force out there. This idea, this different way of looking at things, says that electricity is the dominant force, electromagnetism, right? That gets into things like plasma physics. It's a totally different way of looking at physics. The best analogy would be this. Okay, we've always been told that the sun was a whole bunch of nuclear bombs going off. Boom, 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 boom. Every minute, 1 million Hiroshima-style nuclear bombs going off. Now, the sun's big. It's 1 million times bigger than the Earth. But if these guys are right, and the sun is billions of years old, don't you think all those bombs would have went off by now? Don't you just think it might have happened? It only took a fraction of a second for that one at Hiroshima to go off. And if 1 million of them are going off every second, wouldn't it have consumed the sun by now? Don't you think? Kind of like the comet would have melted by now, the icy snowball going by the sun. You'd think it would happen. But there's no Oort cloud they can manufacture out of thin air to account for replacing the sun all the time. But if the sun was electrical instead, when you rub a balloon on your hair in the dark, you get sparks, static electricity. What if the sun is a giant balloon and it's going through the interstellar medium at extremely high speed? You can think of the interstellar medium like hair. It's a bad analogy, but you know what I'm getting at. What if that causes the sun to be as bright as it is? Maybe it kicks off some nuclear reactions as a result of that, but it isn't nuclear reactions that are driving what we see in the sun. And hey, what do you know? Again, the actual evidence seems to support the idea that electricity is the dominant force, and that we should be looking at plasma physics, not all this old and stale stuff that standard science is so focused on. Okay, now I'm not going to get into details. I'm not saying that's the way it is. plasma physics, electric universe. What I'm saying is that it is compelling and the evidence seems to support it. It needs to be looked at more closely. There's a group of people, scientists, well, for the most part scientists, who they got together because they wanted to investigate this idea more. Good for them. They got together because there's power in numbers. The more of them they have together, they can pool their resources and they become a little bit more immune to what happened to Halt and Arp, which is standard science, the junk scientists who control everything, just picking these people off one at a time and ruining their careers. So they just disappear, like a Jew in Germany, just disappear all of a sudden. They were there yesterday, now they're gone. No one knows where they are. That's what standard science does to these people. There's power in numbers. So they got together and they formed a group which they called the Electric Universe. Kind of stole the name from someone else who created that, and I know it sounds like a good acid rock band from the 1960s, but that's not what it is. This is a group of people who are pushing for more research into the idea of electricity being the dominant force. That's great. That's great. The problem is that they also brought in some other people. Specifically, they brought in one guy who has more or less become the face of this group, which is called the Electric Universe, right? So the group adopted the name of the theory in mind, so their credibility as a group affects the credibility of the idea. You see what I mean? If they had called themselves, the James Gang or whatever, then it doesn't really matter if they're discredited or not. The idea of the Electric Universe remains independent. But they called themselves the Electric Universe. So their credibility kind of, you see what I mean? It goes over and affects the credibility of the idea of the Electric Universe. Well, they brought in a guy, the guy who's standing up as their, this guy is the face of the Electric Universe. And guess what? He has nothing to do with physics at all. This guy's interest is mythology. Great. All right? So he's out there and he's looking at cave paintings and such. Somebody thousands of years ago, he would say probably tens or hundreds of thousands of years ago, drew something that vaguely looks like a candelabra. And hey, when you get into plasma physics, there's this thing that materializes in the plasma that looks kind of sort of like a candelabra. Okay, well, see what you're doing. He takes it just a little bit further than that. From that, he derives this entire Hollywood script where Mars came within a few thousand miles of Earth and a big thunderbolt carved out the Grand Canyon and killed the dinosaurs and locusts and just back to where we are again. Why would he do that? Well, I just told you a moment ago. Tens of thousands, hundreds of thousands of years. You see, the Bible says that the earth was 6,000 years old. That's when God created it. You see, these people are on the right track when it comes to the science of the electric universe. I believe they're on the right track. I think it's fascinating. But they still don't want to give up. They still don't want to admit that God is the creator of it all. So they're desperately looking for a way to throw God out of it. And the only way they can do that is if they attach themselves to things like geology and archaeology, which, through their own junk science, make it look like humans have been around for hundreds of thousands of years. That's why he's there. It's to try to get good science while still keeping God out of it. And when you're that desperate, this is what you get. So their credibility is just shot to Hades by this guy who's kind of a creepy speaker to begin with. Kind of makes my skin crawl just listening to him. But he's talking about mythology, and don't get me wrong, the evidence of documented history is very useful. Those are witnesses, eyewitnesses, very useful. But the fact that they drew some thing that looks sort of kind of like a candelabra, that isn't a documented witness report. It's a stick figure. And you can't tell me that Mars came near the Earth 10,000 years ago because there's a stick figure in a cave somewhere. You see, the Electric Universe group, their videos are like Hollywood productions. They're magnificent, beautiful productions, including artist conceptions of what happened when Mars came near Earth. You remember what I said before about how NASA creates all these artist conceptions of what's going to happen when New Horizons gets near Pluto. And then when you search for it after the fact, since Pluto looked nothing like they expected it to, all you can find are these artist conceptions. So you think NASA was right all along. Same thing here. They're showing you these videos of Mars coming near the Earth so that you have it in your mind, well, I've seen it happen. Of course it happened. Where are they getting the money for that? How much did it cost to make Star Wars? Where are these guys? These guys getting together to try to save their skins from the other group of junk scientists. Where did they get the money to make all that? Some people think it's controlled opposition. In other words, the junk scientists found this group who were trying to push this, that we should look into the electric universe more, which I think we should, but they wanted to discredit them. So they gave them a lot of money somehow, funneled them or laundered them a bunch of money, and they don't even realize they're being manipulated. But one of the stipulations with it might be, for example, you must have as your spokesperson this bat guano guy, in my opinion, who's pushing this agenda that a candelabra stick figure in a cave gives us this script of what happened in the past on Earth, with no other evidence, or no good evidence to support it at all. I don't know if that happened. Honestly, I don't think that's what happened. I really don't. But it is possible because junk scientists often use controlled opposition to discredit their opposition. And believe me, the Electric Universe is someone who they want to discredit. But the point is, these guys have formed like a cult of their own. I think the idea of the Electric Universe is something we need to research, we need to look at. I think they're on the right track. And it's going to rewrite the whole history of physics and astrophysics, astronomy, and it's going to prove, or it's going to show, if they can demonstrate that electricity is the dominant force, it's going to definitely show that you wasted your money in college when you studied that stuff. And if you got student loans for it, and those guys are calling up your children and telling them to write, "My parents are deadbeats" on the wall with lipstick, like these student loan operators can do legally, they can just get away with it. That's just one example of what I've encountered with people who've had to deal with student loans. If those student loans were obtained for the purpose of getting an education, but instead they were told a whole pack of lies, and people like Chandrasekhar knew that it was a pack of lies, they were trying to hide it in fact, that's fraud. And people need to go to prison, including people in the student loan industry need to go to prison. You see how all this ties together. I've got to move fast because we're running out of time. Another group is Reason Magazine. Reason Magazine is supposedly fighting against junk science, and frankly, they do. They have done a magnificent job of fighting against anti-smoking for years. They do a great job of showing the junk science in anti-smoking and climate change and such. And yet, they also support the idea of the government sticking a gun to your head, forcing you against your will to get a vaccination. A cocktail of toxic chemicals that you have no idea what it is. Why would they do that? Why would they do that? Because if you look into vaccines, there's some big problems there. And anyone who's fighting against junk science should be fighting against the idea of forced vaccinations. Why would these guys be against anti-smokers, against climate change, and yet they're for forced vaccinations? Well, the reason is, so to speak, is because Reason Magazine is the publication bullhorn for libertarians. Libertarians are a political party. And again, because of time, I can't go into it more. See, their political ideology is tainting their interpretation of science. So even though they do a great job going after anti-smokers and climate change people, they completely blow it when it comes to vaccines, because their political ideology is dictating what they believe, not a quest for truth on all matters. In other words, they formed another cult, the cult of libertarianism. Moving on to number 3, which I have to move so fast. I'm so sorry about this. Junk science support industries and cottage industries. Academic journals, all these academic journals out there, they get published. And it ain't the junk scientists who are publishing. They're not back there with a printing press cranking out and wiping the ink off their hands. There's a whole industry of publishers who specialize in publishing just academic journals. They employ a lot of people. They make a whole lot of money. They take the journals in PDF form or what have you, some kind of format from the people at the journals. They go through and they proofread it, they format it properly, and they print it. And they ship the journals out to libraries and such. And I'm so cold, my voice is shaking. I'm so cold right now. I have to finish. Alright? That's a huge, huge industry. If you expose these journals as being junk science, guess what happens to that industry? Alright, how about some more support industries for junk science? These junk scientists have conferences all over the place. I've told you about the anti-smokers. They're always having conferences in beautiful exotic locations. Hawaii, Rio de Janeiro, Monaco, whatever. They're not having it in some filthy, rat-infested village in Bangladesh. And the public's paying for it. For the most part, this is being paid for by the public. Well, what's involved in that? There's air travel, there's travel agents. All these scientists go into all of these events, all these different conferences and trade shows and things. They have to travel. Airlines, travel agents, hotels. Remember, I used to run hotels. I know how much these junk scientists travel. Ground transportation, taxis, etc. What about event signage? Whenever they have these conferences, they have to have all these signs and displays and everything. There's a whole other industry that makes just signs for trade shows and events like that. Alright? What about document control? As they're going through all this junk science, they have to they really don't in anti-smoking, but in any place where you're trying to document something properly, you should have proper document control. That costs money. What about protecting it? Iron Mountain, that kind of thing. Documentary films made for TV based off of this junk science. All of these industries employ a tremendous number of people collectively, and they make a whole lot of money on their own. And yet, none of these industries care about the science. They're not scientists. They don't care. They don't care if anti-smoking is a complete fraud or if it's true from the perspective of getting their business. They don't care if Big Bang is true or not. It has no impact. The only thing they care about is that the people who push Big Bang remain as powerful and wealthy as they are so they can keep spending their money on air travel, hotels, signage, etc., publishing academic journals. You see, it goes back to the law of supply and demand. I told you from the beginning, all of these things, these existential threats, are related to each other. The law of supply and demand has been violated here. These junk scientists have manufactured this huge, huge industry with all of these supporting industries and cottage industries that rely on junk science for them to survive. It's artificial because the science was junk. But what are you going to do? If you want to go attack junk science and fix the problem, now you have to cause serious harm to all these cottage industries, all these supposedly innocent people. The publishers, the hoteliers, the travel agents, the airlines. Now you have to have a significant economic impact on them because of the law of supply and demand. You see, this never should have been allowed to have gotten as big of a problem as it is right now. And that's one of the things that keeps junk scientists in business. It isn't just that we can't stop the junk scientists. There's enough prison room to fix the problem for anyone who wanted to. Or we can just build a few more prisons. It's still a whole lot cheaper than what junk scientists steal from the public coffers. But what are you going to do with all these other people who are losing their jobs and losing their whole businesses? You see, junk scientists are exploiting these people. Supply and demand, folks. I am freezing. I can hardly talk now. I'm shaking so much. And frankly, with the time here, I've got to end this video. So I hope you enjoyed this one. Sorry to rush through the ending there, really. But please come back for part 7, I guess. All right? You're going to find that fascinating as well. Thank you so much for watching.